And we are live again. So, welcome to the stream and let's dive right into it. My neighbors were just drilling and hammering away a few seconds ago, so I hope they are done now and won't interrupt the stream any further. So yesterday we left off with the ESP communicating to the ATtiny441, and we managed to get a serial speed of 1 megabit per second, which results in a update speed. So if we want to have an update of 60 frames per second, so 60 times a second for the whole LED wall or tile wall, as you might say, then we can get at most 79 tiles at the same time, which is already a lot, because someone said yesterday that the original Nanoleafs only support up to 30 without changing the software by yourself. So that's already a success. And also what has come to my mind was that if we don't want to update all 6 LEDs of every tile, we can even control more tiles than that in that time period. So let's switch to my right screen for a second. Let's have it like this, so we can see the thing doing its thing. So here I've got a calculator. So 1 megabit per second results in 100,000 bytes per second, because we need 10 bits to transmit 1 byte, as Johnny pointed out. So if we have this value and then divide by the packet size, so 1 packet is for the larger ones 21 bytes, the smaller one is only 5 bytes. So what did we need to... Alright, so this leads us to 20,000 packets per second. And if we divide this by 60 FPS, we can actually control 333 tiles at the same time with an update interval of 60 frames per second, which is a lot, I guess. Also, my implementation of the tiles only support up to 250. Let's look at the code. The most we can do are 254, because 255 is the broadcast address. 0 is not a valid ID because it's reserved, and then we only got 254 IDs left. So yeah, we can pretty much control all tiles, or the maximum amount of tiles I designed the software for. Because if you wanted to get more than 1 byte of ID, then we would have to send 2 bytes to identify each tile, and this will result in more data needing to be sent out. So today's stream will be more on the software part. Hello, Bolokan, how's it going? Are you working on your metrics or your hexagon clock project at the same time while watching the stream? So first of all, I want to fix the code which we are currently sending to the LEDs. I want to have a nice rainbow pattern across all LEDs, which is spread out. But currently we are just sending the red channel to the first LED, the green channel to the second one, blue and to the third one, red and green to the fourth one, green and blue to the fifth one, and red and blue to the sixth one, which results in this color scheme. Just relaxing. So I hope you have a good drink or something. So what I want to do now is that I know that I have somewhere, I think even on GitHub, code for the color fade, which will do it across all LEDs. What are repositories? This one was the correct one, I think. Yeah, the sender. In here somewhere, I think I have this stuff. Twinkle color loop. There we got it. Alright, this color HSV, I think is an implementation. Hello Ben, how's it going? Is an implementation of my own? I'm not sure. Color HPP. Where's the color HPP? Oh, it's right there. Alright. So for the controller, I think I will just copy this code right here and include it in our project. Let's see. So the project is on. Is it here or no? I think I have it under documents, repositories, triangulum, and then controller code. Let's create a new text document. Call that thanks. Color.hpp. Yes. And then open that with Visual Studio Code. We paste our color stuff in there. I hope CMath is available on float modulo. I don't know if CMath is available on Arduino or not, but I guess. And we will also need, wait a second. Oh, this is the wrong, all right. Let's reopen that and then create the new, let's just copy the file. Color.cpp, yes. Put that in there, and then we do color CPP. Copy all the nice code I wrote. Save that, and then we can use hue saturation instead of RGB values, which is easier to spread the color across a number of lights. or the math is a little bit simpler. So in here we can go to color loop, pretty much copy this code piece, and then we will go to our controller. Math is part of the ESP8266 framework. Alright, then, and what about algorithm? I hope so too. We will see in a short second. We don't want this because we don't have that. And we need the set color all. Strip.show. Oh, now I'm really talking in German again. Color offset is LEDs. Let's add a constant. No, maybe let's not add a constant. Let's do a uint 8t LED count equals, for us, 8 at the moment. Technically uint 8t, no, 6, I'm wrong. Tile count, we will need that later. It's 1. I think we can make this one constant though, constant LED count, and then we will do the proper formatting, because otherwise I will get a stroke while watching this. So what we do for the color offset, hello Vio, how's it going? So for the color offset, which is pretty easy, we calculate 1 divided by the LED count and multiply that by 360. And this will give us the offset between the LEDs to get the rainbow effect spread out. Since we have the set color all command, we don't need the loop right there, and we don't need the LED strip or the strip.show. But I guess we need to do it a little bit different, because we need to keep the color values. ESP8266, Arduino Blockmaster Tools, SDK, libc extensor, elf include math.h. So I only need to include math.h. Alright. std fmod. Alright, so let's think of this. The cheesy way would be to just have multiple instances of this. So I could not paste the link. Oh, right. I can permit you to do that, to only send 1. Oh no, that's not. Oh, I forgot. We are not on. I don't know. If you paste the link, I can probably accept that link. LED color 1 equals color, and then LED color 2. Hello Rohan, how's it going? equals, oh now I need to look into the color implementation. Struct HSV, we are using the color HSV. We have an equals operator and we have a constructor. So we could do color and then do a constructor thing. LED color 1 dot H. No, wait. Can just use that. We do this and then LED color, set color. Wait a second. No, LED color 1 dot H plus offset color and then LED color 1 dot S, LED color 1 dot V. So hue, saturation, and then velocity, or the brightness in that regard, or the darkness, and it depends on what you're looking at. So 3, 4, 5, 6, 4, 5, 6, 2, 3, 4, 5, 2, 3, 4, 5, 2, 3, 4, 5. Stream broke? Not for me. I have a warning that the bitrate is lower than the wanted one. Maybe it's because the stream is set to extreme low latency. Forgot to set that to low latency. This will also increase the quality. But I can't change it right now. I would need to end the stream and restart it. Let's see. So if we then have the color, we can convert that to RGB. I think. HSV. Alright, I need to look at the reference implementation once more. Strip.set color LED. Alright, so that one is using the color thing. Ugh. So we have the color HSV, which is, we now want to convert that to RGBW. There's probably a better way of doing it. Color RGB LED color 1 RGB 1 2 3 4 5 6 2 3 4 5 6 2 3 4 5 6 probably this won't work. So color RGB has RGBW. Oh no, RGB only has RGB. Yeah, I have an implementation for RGBW as well. R G let's change the rows a little bit. Wait, RGB. Alright, I forgot one there. Henrik, good news everyone, I have joined. How is it going? So now it's correct. So now I will just copy this over real quick and then we can change the numbers. So this needs to be 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. The question is, how is it going for you? Oh, it's going good, I guess. What did I miss? Oh no, I have just one. Too many. So this should work, I guess. Color, let's look at it again. Color equal, offset color equals color. Then we calculate the color offset. How can I control the lights in the back in Twitch chat? If you go to Twitch, there is an explanation in the description of my channel. I only linked the chat itself, so you might need to remove the extension of the URL. And then I hope you will find what you're looking for. So yeah, if you don't find it, then let me know. It's not defined. Pretty rookie mistake. We're missing the equal signs, and then I think we also need to do this. Yep. So now, will this compile? Oh, wait, we forgot to include. Oh yeah, Bolokan, you sent me the link. There's the link. Totally missed that. This again here. Can we? No, it doesn't. Won't close. Need to include color.hpp, and then Arduino should not conversion to non-scalar type requested. Function void color loop. Error, conversion from color RGBW to non-scalar type color RGB requested. Color HSV, we have color HSV. Oh wait, I used the wrong function. Nice, that compiles. So is it set up? Yes. I think I need to remove the receive pin. And then we can try that out and see if I did anything wrong. Hey Johnny, how's it going? See what you did there. Oh yeah, Rohan, you need to remove the brackets. You're already the second person who didn't know about this, so I might need to make a bigger note on that. Also for the second light you will need to do dimmer to 200, dimmer to 255. Yeah, now it's turned on. Any progress? Yeah, we implemented the color loop from my other project, where I also have a proper color class that I implemented, which can do conversion from HSV to RGB or RGBW, because it's easier to make a color loop with HSV over RGB. So we just do a little color offset and generate our HSV colors, then convert them to RGB and then set the color. But need to remove the call to cycle LEDs and call color loop instead. So let's upload that again, and then hopefully we get a nice rainbow effect, like behind me. And something seems to be wrong. Oh, not this again. Give me a second, I will just close this. Thanks. So color loop, no problem, don't worry about it. Color loop does not work. Just do it afterwards. Right, are we missing something? So we have red, oh no, not red, we have hue 0, which should be red. Saturation 1, which should be the most saturated, and brightness of 1, which should be completely bright. So at least the first LED should light up, which it is not. So I'm wondering if the RGB conversion is working correctly. Alright, since we are not interested in the hue and saturation, we can also, no, not interested in the saturation and brightness, we can replace those with ones. Which should at least give us some sort of color. And if this doesn't work, we might need to do a little debug print, but we need to keep in mind that the data is also sent out to the microcontroller. So this is not working. Let's do... we can't do std out. So let's do serial.println. Oh, not serial.print. H is V. Oh, I wish this would work on Arduino. Offset. Right. Read this. For that one. And then this right there. And then do HS V, and then we will do a serial print. ln. Hopefully this will work. And then we will open the serial monitor and set it to 1 megabit. Alright. 1 megabit. So the hue saturation is going through the colors. If I remove these, let's see, we should reach to 360 and then jump to 0, which is working. So let's copy this and then go down here and see what the RGB conversion is doing. Because I think I was using the RGBW before, so there might be a bug in the software. But technically this should work. Because trust me, I got it from the internet. Or Stack Overflow, which is a great source for awesome stuff. So hard resetting, let's see, RGB. Yeah, so I can already see what's wrong. Obviously the value is not Stack Overflow programming. So let's see what RGBW is doing. 1 second. I want to see the Alright, yeah, I didn't look at my own documentation. What we need to do is multiply by 255 to convert the float or double value back to, or not really back to an integer, but we are expecting values from 0 to 255, and our conversion is outputting values from 0 to 1. So I will also remove the serial print because that will confuse the microcontroller, and then upload the data or the code, and then we should hopefully see a color loop. Oh, that is ugly. We need to change the step size. Let's halve the color speed, I guess. Or let's not half. I divided by 10, so let's make it 10 times slower. Oh, and also the microcontroller reset, so we need to... No, we don't need to do anything. Alright, so let's... Interesting. So the first LED is working correctly, but the others are a little bit wrong. So there's an issue with our calculation right here. All right, let's see. We're doing LED color 1 dot, so LED color 2 hue is LED color 1 hue plus color offset. Hey Chris, how's it going? Plus color offset, and then modulo 360, so we don't get a higher number than 360. Training till 7. So you're all worked out now, or alright, what am I missing? We are converting 1, 2, 3, 4, 5, 6, so that should all be correct. We are RGB, 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 and RGB, RGB. So there seems to be something wrong with the fmod thing I'm doing. But technically there shouldn't be anything wrong with that. The LED count is 6, so we are dividing 1 by 6 and then multiplying that by 360. Maybe let's do a serial print of all the colors. Or at least all the color values. So 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. The last one will become a serial print ln, and then we will have LED. I think it's just quicker to go through and change it by hand. Alright, upload that real quick and then We'll look at the serial monitor once more. Let's also do this. Mind blown. All right. So this looks very interesting. LN stands for line. Yes. Print and append a line at the end. $160. To me, it looks very long. If at first you fail, just give up. Why just give up? Alright, there's clearly something wrong with this. Let's also print the color offset. Color, or let's just do offset. Then I will just copy this. Maybe there's something weird going on. Technically there should not, or fmod is differently implemented. Plus color offset. Debugging it is again. To me it looks very long. Hard resetting, serial monitor. So the offset is 60. Which looks fine to me for the values. Hey, why is it working now? Didn't even notice that. What? Let's remove that serial print for a second. Are we sending the data too quickly? All right, let's do something different. You have a Heisenbug. What is a Heisenbug? All right, color loop. Software bug that seems to disappear or alter its behavior when one attempts to study it. Yeah. That's a nice description of the issue. So let's do our thing right here to reduce the amount of time the function is called. Maybe this should also, maybe this will already fix it. Yeah, so the color fade was just too quick. We now have a delay of 1 millisecond. Is it micros? Oh, I hate it. Why it never works? So yeah, it was just too quick. But that looks fine now. Let me check over here in real life. I will zoom in a little bit more for you. Yeah, but now we got a color fade which is equally spaced. So we have red, 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 and then the red starts at the end again. And 1 microseconds equals it's bigger than FT. 1 millisecond is more than 50 FPS. Yeah, because it's we have 60,000 seconds. No, wait. 1 second is 1,000 milliseconds, so 1 divided by 1,000 would be our what's the English term for it? Frequency. Oh, wait. Oh, am I mistaking something? Should have listened more to physics class or math in that regard. FPS equals frequency. It's 1000 FPS. Yeah, once every 1000 milliseconds. No, wait, once every millisecond. Yeah, it's 1000 FPS. Yeah, but we only get 1000 FPS if we control one of them. Also, Johnny, so the calculation last time was 100,000 bytes per second. Since if we only update the whole tile as one thing, then we only need to send 5 bytes. So one command byte, 3 color bytes, and then 1 end byte. So if we divide this by 5, we can send 20,000 packets per second. And now we need to divide that by the FPS you said. And then we can update 333 tiles at 60 FPS. Was that the correct calculation? Microseconds, 1 millionth of a second. Millisecond, 1,000th of a second. Yes. We could also use the micros and see how far we can push it. It was 39 if we update all LEDs. So the calculation for the other one would be wait, what did I do? No, not why did I, yeah, it's 100,000 divided by 21 bytes, and that one divided by 60, so we get 79. And 30. Yeah, so we can only update 79 tiles simultaneously at 60 FPS if we want to control each individual LED. But if we want to control the tile as a whole, we can go up to 333 tiles at 60 FPS. So, since the maximum number of tiles one controller, or since the maximum bus size is limited to the number of IDs we can set, which is 254, we could even do more than 60 FPS with the largest amount of tiles possible. Is there any information on how quick the original Nanoleaf can be updated? Or what their update rate is? Because technically, if you have some sort of animation, you won't even need. But you only have 1,000 LEDs, so... Yeah, I only have 1,000 LEDs, so if I would make... If I have 1,000 LEDs and I need 6 for each tile, then I can make 166 tiles. Bitloony will know. I don't know. Yeah, we can only do pretty much half of that. Yeah, exactly half of it. Which is also interesting math. That 1,000 LEDs perfectly, so I would need 2,000 LEDs to max out the whole thing. It's not butter related. Oh, I like where this is going. So, how big is Bitloony's large LED wall? I think, or I guess those are more than 1,000 or 2,000 LEDs. That is a shitload of leaves. Yeah, I don't think that JLC PCB will sponsor me 333 PCBs fully assembled. And then I also would need to buy another batch of 1,000 LEDs, but I could probably pretty much fill up all walls of my room, which would be crazy. I would love to do that. So once I have my, once I have a house, Nanoleaf has 30 FPS. Oh, that's pathetic. No, not find a big ass wall. I would just get like a house and then the new studio, or like this, the new how would you call it, lab? The new lab would be then just, or the new streaming room or whatever you want to call it, would be just only these LED tiles on all walls and the ceiling. Maybe even the floor. 10,000 LEDs? Yeah, why not? So if we have, let's do the calculations for 166 LEDs. So I know that one LED takes at most 180 milliwatts of power. So if we already have 1,000 LEDs times 0.18, we would already draw 180 watts of power at full brightness. And power is current times voltage, so at 12 volts Power is current time voltage, so current is power divided by volts. So 180 divided by 12, we would need a 15 amp power supply. Hey Michael, how's it going? Chris Crafter, 20 milliamps times 3 per LED times LEDs. No, your calculation is wrong, Chris, because I'm using the WS2815, which are 12 volt variant, and they, even at full bright white, only take 180 milliamps. I just wrote them down. Yeah, so we would need a 15 amp power supply, and I guess only is power equals voltage times amperage, I know. Yeah, and then U equals R times I, so voltage is also resistance times current. So 15 amps, I guess a pretty standard, let me wander off for a second, because I have a PC power supply right here, and that can do 12 volts, 320 watts max, so 12 volts, 19 amps. So the PC power supply should still work. As I calculated right here, we have, where is it? We have 180 milliwatts at 12 volt. And also what I got, if you know the video of, what's his name again? Oh, this is embarrassing. So over here, are you changing over, NV? I'm probably just testing with YouTube, and maybe we'll go back to Twitch, because the bots are easier to make for the Twitch one. So Julian Illet just released a video a few days ago, or yesterday or what, where he showed that you can use these server power supplies from Hewlett-Packard to power anything, and these are just 12 volt power supplies, and they can provide 38, or this one is the small one, this one is only the 460 watt one, and this one can provide 38 amps at 12 volts. And Julian showed that you can get these adapters, which you can just plug in the front with, because this is a proprietary connector, and then it just yeah, for his Bitcoin miners, exactly. And then you can just plug in cables, or the standard PC cables to it, to distribute the power. So I could use this single power supply to control 2000 LEDs easily. So because, as we calculated, 1000 LEDs will take 15 amps, and this one can provide 38 amps, so we even have 8 amps room. And these power supplies, 1800 watts, 10,000 LEDs would be 150 amps times 12 volts equals 1800 watts. Yeah, 38 amps. So we would have still 8 amps room, and I know that these server power supplies can be really pushed to their limits, because they are actually designed for that purpose. I don't know why BitLooney didn't use one of these for his ping pong LED wall, because they are pretty cheap, and he got this huge 12 volt special power supply And this would have been a pretty cheap and easy solution, I guess. And I already ordered one of these adapter boards. So this is what I'm going to be using for the Nanoleaf wall, I guess. But there's still a lot to code. Made a video about several PSU solutions and he came out with the right one. Yeah, he did, but he didn't use the server power supplies. So he probably didn't know about them. I also didn't know that it is a thing that there are adapters for these power supplies. So you can just hook them up to anything, because I have 2 servers down there and I still have 2 of these power supplies in the servers, because this one, it's still working, but it had an issue with its fan and I just got it replaced for free. So now I have a free power supply I can tinker with. So what I also wanted to try is, if we just increase the LED count to 12, then we get a nicer color loop. Maybe we could even make this a thing of WLED. So you could use the ESP8266 and the web interface for controlling it and have the nice GUI. Like for the lights in the background, I have the WLED for that. And now it's doing some kind of animation. I can go back to the color loop. My mom just brought me food upstairs. She never did that before. Thanks, Mom. Oh, you have a nice mom. Well, my mom is very far away, so she can't bring me any food. His miners were only 70 pounds as they were too slow already again. Yeah, Bitcoin mining is pretty much a done topic. But I know there's also, I also picked Chris' mom. I have a WLED strip under my desk. With WS2818Bs, the data speed is 800,000 bytes per second, which is 30,000 plus RGBs per second. Thus 30 FPS with 1000 RGB. Bits per second. Oh, not, do you not check Discord lately? BPS not equal to BPS. Yeah, bytes per second and bits per second. Well, then I can do more than it, because I can do 60 FPS with 1000 LEDs. No, not wait. I can do no. I can do, if we can do 79 tiles at 60 FPS, then that is 474 LEDs. So 800,000 divided by 24 bits is approximately 30,000 RGBs per second. Yeah. And if we can do 333 at 30 FPS, those would be 1998 LEDs. So we can do 2000 LEDs at 30 FPS, yes. Dark theme doesn't stick out. Yeah. Can I make it any larger? Oh. This looks better. I think 30 is enough. Oh, tell Linus Tech Tips that. Alright, so since this is working all, and I have at least something nice to show with the color loop, I think it is time to get back to the tiles and the PCB. So if we remember, these are the PCBs we designed. Datasheet 30 FPS times 1024 LEDs is possible, confirms the above. Well, I can technically do twice that at 30 FPS. Since I'm not... So the difference here is that I'm communicating with the ATtiny, and this one in turn is then communicating with the LEDs. So technically speaking, if I have 333 tiles, then I also have 333 controllers controlling the LEDs. Can the LEDs even update 60 times a second? Yeah. For a string with only 6 LEDs, that is pretty easy. I mean, we are currently doing 1000 FPS with the color loop animation over there. Because we are sending data every 1 millisecond. So 1000 milliseconds or 1000 times per second, so we have 1000 FPS. Which is crazy. But if you think of it, we are only updating 6 LEDs. So that's not much. So technically I'm at the point where I want to order a few of these tile pieces, so at least like 5 of each, because we need 3 of them. So we could do 5 test tiles, and I would like to have the test tile first before continuing with the software, because update frequency is maximum 2 kilohertz, will be the PWM of the IC inside. Yeah, probably. I mean, there's can the LEDs even update season? Yeah, there's always some bottleneck. Then you would need to get better LEDs with better PWM ICs. But I guess the faster you go, the more problems arise, I guess. Because then you also get some other effects with the higher baud rate. The bottleneck is the bottleneck. Yeah, and then we need to get rid of the bottleneck of the bottleneck of the bottleneck. Glass fiber between the ATtinys. Yeah, that could be a thing. But I guess then the 16 megahertz, the gold, red. Then the 60 megahertz crystal or resonator won't be enough. I think then we would need to go higher, and then the ATtinys would use more current. Alright, enough of that. So this is the PCB, and I want to... Can I have a new tab? Let's go to... Do you think the panels are way cheaper than the originals? Yes, they are. Yeah, it can do 20 megahertz. All right, so one thing at a time. Let's go right here. So clock options. External crystal or clock up to 60 megahertz. Overclocking to 20 megahertz is possible. But I think then you will maybe get stability issues. I don't know, but it is a thing. Yes, I'm running on 5 volts, so 20 megahertz would be a thing. They typically work without issue at 20 megahertz at 5 volts and room temperature. Yeah, but I don't want to push it that far. So, to the other question, are the panels cheaper? Yeah, probably you can get the PCBs, typically. So, if you get the PCBs, you will probably pay 5 euros for 5 of them. So you would get 5 triangles for 5 euros, and then the components are like another $5 for the microcontroller and other components. Water cooling for the win. So where I wanted to go to, what is this software of JLC PCB again called? The online PCB thingy, PCB routing stuff. What's it called? EasyEDA, there it is. Alright, I will log in. My mind is blank. Why is your mind blank? Why can't I log in? More than 1 million free libraries, integrated LCSC component catalog. Ah, country area. This is a nice country area. So, EasyEDA design. Yeah, I also couldn't remember EasyEDA. It was like I never heard of it. So we want to open a keycut file, and then we select this here triangulum zip, and then click import. Oh, I also need to get a haircut. Hair is so long. Tip, press space or R to rotate the placing object or selected object. Why is it taking so long? So, can we add the break of tabs somehow in here? Triangulum, check Stack Overflow. EasyEDA add break of tabs. I got my hair dressed today. What a weird shape. Also, we got easy. I think the penalize multiple designs. Yeah. We don't support this at present. That was 2 years ago. The penalize only support. You can try copy and paste to penalize A and B. Thank you for your fast reply. Last week I rose an cut paste method seems to work obviously. Rows in order using some cut and paste of A and B. Wait a second. I've got a project based on 2 different little PCB models. Each model has a different design, let's say design A and B. Is it possible to have both A and B on the same board to be able to order 1 project per board? Question 2, from there, is it possible to penalize, so can I put n times AB on the same board? We don't support this at present, the penalize only support itself. What a nice English. You can try copy and paste to penalize A and B. Alright, so he penalized it himself. Last week I rose Model was rejected after some hours stating there was several designs on the board. It's a bit annoying as my designs are just prototypes in this step and I would like to avoid ordering separately 2 different series. Are there some limitations from JC PCB about this cut-paste practice? So the other guy also did this. So here's the Aurora Nanoleaf clone, and he made his break-off tabs inside Easy EDA. But I think he just made them himself. Especially, I would let JLC penalize, especially since they will run it in their pick and places. Yeah, that's also the issue here. But then we can't have all 3 designs on one board. You would then need to split them up again into 3 different things again. Which we already did. We have the PCB A, B, and C. So if I open this real quick. Yeah, the issue is currently that you can't have 3 different designs on the same panel. But if I want, yeah, Johnny, that's a pretty good call. That probably if I add the break-off tabs myself, maybe JLC PCB will have issues penalizing, will have issues populating or pick and placing the boards. Yes, continue. So can we have them side by side? So this one is the first one. I just want to make sure that these are really the same, because technically I should delete the master project, or at least rename that really quick. PCB all. So if we then close this and go to JLC PCB, quote now, are the Gerber files correct? Well, let's see. PCBA, Gerber. Oh no, it doesn't work. Documents. No, not. What am I doing? No! Repositories, triangulum, tile, PCBA, PCBA. Processing. So you can get 5 of them for just $1.70. But if we do penalize by JLC PCB and then do X1 and Y, no wait, what? No, Y1, X3. How big is this? 4. Yeah, you could get 4 of them, and since we get 5 PCBs, we would have 20 already for 630 times 3 plus shipping. And then SMT assembly. Alright, so only below specs are available. 2-layer PCB, we have that. 2 and 4-layer min. Thickness 1.6, green solder mask, 1 ounce of copper, only tap routing. Oh, panel by JLC PCB is not supported. When you order 5 or 10 pieces PCBs, you can get 2 PCBs assembled by JLC PCB and solder the remaining PCBs yourself. Why should I do that? Poor David Watts confused PCB way with, yeah, I also saw that. So I want to see this in Gerber view for a second. I would like to have the white one, just because it would reflect the light a little bit better. But maybe black. Ooh. White. So the white one with LED free is really white, and with LED it was yellow? No, Anic rose. No, the nice butter color with Anic. That is butter colored. Or do you mean even yellow and then Hazel, LED free, Anic? Shiny. Analysis result. Okay, that looks fine. So Let's see. I don't know what would be best. The first soft yellow butter. I would like to get them in white, maybe. Oh, Anic Rose is really expensive. Lead-free hassle, or hassle, as I would call it. Please lead-free. But it's so much more expensive. It costs like 15 euros more. I'm glad that you asked, Johnny. 2 and 3 are... let me open that real quick. Open project. I will just open the all one. So the issue is, since we want to detect which side is connected to another tile, can you please go away? Thanks. We need to route the side C1 to the right one, which connects there, and the side B1 to the left. I'm also already seeing that there's an issue right here. There are some wires missing. Interestingly. Don't know why we missed those. So now I need to recheck all of the boards. Yeah, they have an issue. So PCBA was the one which was missing the wires, and I think I added them right here. What connectors do you want to use? I will just do. I will have the. Let's look at that with the 3D viewer. I will just connect, or I will add the boards next to each other or line them up, and then just solder directly between the boards. And we will do that on both sides. Yeah, arrows. Oh, they now have a nice animation. Look at that. Ooh, so smooth. Solder blobs for the win. Yeah, it's the easiest and cheapest way. Also, what I already almost forgot is that we also need to make a little PCB for the interconnections. So we need a PCB which will interconnect the tiles to each other. And I think I would like to make it so that the interconnection PCB has a little hole in the middle, so you can put a screw through the interconnection piece and then just push on the tiles, like Bitlooney is doing that with his big ping pong wall PCB thing. I think that would be a great idea to mount these things on a wall, so you can just use the friction of the connector. And I think I will just use these normal pin headers. We might have to look into that, because then we will have a little space between the wall, but since there's also, we also need to design a 3D printed case for this. Oh yeah, the connections between the tiles, yeah, that's what I was talking about. Yeah, we need to do a little daughter board PCB, which will have, so this connector isn't shown the right way. It's just the way I laid them out. But it's fine, the 3D view is not that correct. Also, the programming header won't be soldered in, I guess. So yeah, we will need a little board which can plug in right here, and then you can just plug in another tile. You could theoretically fill a whole wall with these, yes. Yeah, 15 amps for 1000 LEs, yes I can, and I will. I need to ask JLC PCB on how many tiles they are willing to sponsor me. Like, wouldn't it be crazy if I would ask them, hey, would you sponsor me enough tiles so I can fill an entire wall with them? The pin headers only support 2 to 6 amp per pin, which is fine, and power distribution will suffer from the start to the end if applied on the first module. Yeah, that won't be a problem, because if you think of it, I will need an explanation image. Nanoleaf images. So there are two different cases. So for a case where you have a long line of tiles, then the power distribution will become an issue, because you need to go through this tile, then around the corner to the next one, around the corner to the next one, and so on and so forth. But if you just put them on the whole wall, you could technically be fine if you just plug in 12 volts over here, and on the other side, because since you have the interconnections, well, those are the rectangular ones. If we look here, you technically have multiple paths. So if I connect power over here, then this connector will have the whole amperage. But if I technically connect over here and over there, then I can still get the double amperage, because then I have a path going through on the right as well as on the left, and since those interconnect, I think there are enough parallel traces which can make this work. Also, this looks gorgeous, I think. But imagine this on all four walls and the ceiling and the floor. I think that would be heaven for a bit loony. Yeah, or this year. So if I would just connect power on one end and on the other, then I will be fine. But that's all things we can test. But I'm still not sure whether I would like to get the white PCBs or the black ones. Also, the issue is that the SMT assembly is only available for the green boards. So I'm kind of thinking I might ask them if they could do it for me in the other color, but that probably won't happen. So I think I will probably, for the first run or prototypes, just order the white ones, because I have the red ones from them. White PCB makes the light reflect on their surfaces. Yeah, that's what I was intending. So even though the LED should already spread the light by itself, I think the white PCB would help hide, first of all, the PCB behind the plastic, and as well, so the colors of adjacent ones will mix. It depends. So if the idea is to print a case for each and every tile and then have it enclosed in the case. So that's why I didn't order the connector PCBs yet, because technically we would need to wait until I've designed the case for it and then do the proper connection. It's not that many components, so hand soldering is not really an issue. Well, if I want to do 127 of them, then I will have to hand solder 1000 LEDs. But still, I have to solder the LEDs nonetheless by hand, because LCSC does not have them in stock. So if I go to WS2815, they don't have them. Yeah, for the first order that's fine. And I will hand solder them, and we will probably do it on stream. But that will take some time until I get those PCBs. But hopefully, if I order them after the stream today, because I don't want to share my address information, I will maybe get them next week, hopefully. Johnny, he just asks Mark. I'll help you a lot. Soldering. Yeah, so JLC PCB only has the WS2812 ones. This one is the straw hat one. Yeah, so they pretty much don't have them. But at least they got all the other components. But the other thing is that for the SMT assembly to work, I need to provide them the BOM. And I think it is currently not included in the uploaded files. So I think the easiest way would be to put the boards up on EasyEDA, because then I can link the parts to the correct ones from LCSC. Maybe let's do that right now. But for real, I can help you. So how do you want to help me? You want to come by and solder the whole day, or order them yourselves and test them at home? It'll explode in their hands. The Femto is cool. And he made awesome badges. Yeah. Oh yeah, the Bodger and the police. No, not police station, it's the TARDIS. Einfaches EDA? Einfaches. Like that. So, Easy EDA Designer. I think I have a project. So, how does this work? Open project. Open project. And we. Is this the old one? Yeah, that's no, wait. No, that's just the correct one. I have his TARDIS, but unpopulated. Oh, you lazy. Can I delete this? Alright, we will delete the project real quick and then do a new one. Confirm, yes, bye bye. Projects. Open project. Alright, so let's do file, new project. Or you want it bare? My spelling sucks today. Alright, so triangulum Save. So now I want to import, oh no. Did we export all the projects already? PCBA. No, so let's delete that. I gave me one without components, not sure what goes on. I guess the 555, yeah, 3 volt 555, the LT1. Oh, he sent his failed design ref board. Yeah, that's why it's Bodger the Badger, or yeah, something like that. Alright, so we need to open this project and then do zippity zip, and we will call that site A. Save. We will close that, then we go to B, open that, zippity zip, and then do site B, close that, then we go to the PCB-C and also do zippity zip and call that site C. Fix this bodger in an unexpected way, got Mark surprised to find the bodge requirement. Like you sorted something wrong. Alright, so now we do open keycat, PCBA site A, open, import. How can we rename this? Turned out he sent me the wrong faulty version. Hahaha, cool. But I sent you a working one, Mark. How can we rename stuff in here? Design manager? No, project. How can I change the name of this file? Save as? Project envy, triangulum, and then title site A, save, file save as. Can we also save that as, no, save to existing project, triangulum, envy, save. So now, where did my schematic go? Oh, there. File, save as. Save to existing project. So what happens if I do open keycard again? Thanks, Vio, for giving me €3. The first, what is it called? Super chat, I guess. Because I only have it in German. Need more peeps that speak Dutch to do that. He sucks at Swedish, but he has been here so long he starts to suck at English as well. Yes, I am monetized. On YouTube I am monetized, but on Twitch I am not. Didn't notice that. Such sweet animations. Twitch has bits, but you need to be a Twitch something in order to be able to do something like that. Side B, open. So now I want to do file, save as, and then side B to existing project, and we save. So how do we now transfer the side B thing? Save as, save. Triangulum exists. So what do we do now? Copy and then paste. Save that and then close this. Don't save. And then we also do open KiCad. Did I get an animation in my stream, or is it only in the live chat? I didn't even look at that. Side C, open. Learn him proper Svensk. Emma failed. Oh, import. So we do file, save as, and then side C. He lives in Skane. So he learned Skanska. Copy and then do a little pasty paste right here. Save that. And the super chat animation. No, I mean inside the stream, also what in front of my screen here. No wonder he can't talk Swedish. Oh, that is much different. Scone, you say. Squana, you say. Say. Super chat. Scorn. Swans, eh? Alright, so now we have side A, B, and C, which, alright. In here, and now we need to tell this software what component we got. I learned that wrong back in then when I was one day in Malmo. Add parameter. Add parameter. And then Malmö. Or do we need to do it here? Oh yeah, there it is. Footprint. So search. We need the ATtiny. ATtiny441. Oh, don't they? Oh, do they have the ATtiny441? They should. For me, there are more options. Johnny, we have a province in the south called Limburg, and the southern part speaks really weird. I got the software. Though. Truth. Speak. Yeah, sorry. Not O with dots here. German O gets Ö when not no having the right keyboard, so it did that too with Swedish. I can do the same. Alright, so we need the SSU version, so this one right here. What? Why doesn't LCSC... what? I don't get it. The part number is right here. Oh, LCSC part number. Probably need that. Maybe. Are you kidding me? Umlaute people versus non-umlaute people. I'm just a fake Swede, so John, you make feel away now. You need the footprint name, not the part name. Well, the footprint is correct one. Oh, so supplier part is where I need the part number, I guess. Datasheet supplier part. So the footprint was right, but this is the datasheet. But this is not the ATtiny44 we want the ATtiny441. So do I need the LCSC part number, I guess? It was a PM I sent on Discord. Found it, oh good. I never use EasyDA, nice to see how to use it. hidden behind a ghost avatar. Yeah, I hope that is how you use it. Wait, what? Come back. Oh, all these things in the way. Get out of my way. So name ATtiny. No, we need to change that to ATtiny441. Does it have the correct website now? Probably not. No. Yeah, I won't fix that. Alright, next up. Stop bothering the umlaut people in the chat. Alright, so next is this thing which we looked at before. Do I have something in my shopping cart? I am smart because I added the correct one already. So easy EDA model. Yeah, the footprint looks a little bit different, but we have the hand solder one. By the way, got around to mail you the package today. Nice! Chatmates forever. Oh my chatmate, I will forever bother you, Johnny. Oh, the stream is already ending soon. Oh, I need to work quicker. Also, thanks, Johnny, for sending. I just sent an update about something to Henry. So where's the footprint of this one? Right, so this one, supplier LCSC, supplier part, this one. Save. Oh, the diode, yes, the diode. So the diode, this will be a, so the issue with the diode now is that the reference design uses the 1N4148. Or are we using the, no, wait. Where do I have that part? Oh, it's a mess. LL4148. That's the one I have. DO35 is the package. You are cheating on me. I am. Then you have Mark. Lol. Better to chat cheat than romantic cheat. So wait, what? Johnny with the colors again. So is there an SOD? So should we use the SOD123 one, which would be this one right here? Let's look at that. Beepity beep, my clock goes off. Yeah, and in the background there was some Martinshorn. Do you know what that is, Johnny? Let me also open this PDF. So fast switching speed, polarity, whatever. Nope. Alright, I will give you the term. Then you can look it up. Alright, so yeah, let's just use that diode then, I guess. flyer part and LCSC. I'll save that. So we have the diode, we have the microcontroller. Oh, we need the AMS1117. So close these. AMS1117. You need a food and sleep clock. Alright, AMS1117-5. So what's the difference between these two? They're both SOT223 and we also want SOT223. Ah, yeah, now you got it. Oh, wait. So the manufacturer, we have different manufacturers. We have Puolop, Kexin, and alright, let's drop out regulators and then I will just select the 5 volts. Why is the site not loading? Alright, voltage output fixed 5 volts. Apply 7 remaining, that's nice. The one with the most in stock, yeah, because you all want to order them or what. So let's also arrange by price. Voltage input max 30 volts. Voltage dropout. Output current max. Yeah, we pretty much need a pretty low current. So the 800 milliamp one should be enough already. Which is this one right here, which costs 4 cents. YouTube don't like the F word, yes. So what is your opinion on this one? Should I get the 1 amp version or the lesser 800 milliamp version? I mean, there are more in stock for the 1 amp version and the 1.3 volt dropout. But I don't know if it will make a difference on the efficiency because we are only powering the microcontroller with that and that won't use 1 amp of current. Luckily, I'm a nice moderator. Yes, you are, John. That's why you are a moderator. Yeah. But probably in German you would also use a different word. Yes, that's what yeah. You already said that. All right, I want to look at the data sheet. Ah, yeah. Uh-huh. Butter I need to bring. Oh, also we don't have all the capacitors. Oh, that will be fine. No capacitor, or maybe I don't want to add capacitors. We have 1 capacitor, so that will be fine. Oh, can't type the SS symbol or the hot S. Hot S. That's what it's called in German. So what's the efficiency chart? Temperature, percentage, microseconds. Oh, load. That's what I wanted to see. 800. Oh no, that's decibel. Please use capacitors. We have capacitors. There's one right there. And all the LEDs, what diode is these? Alt. It even says small. I'm on a laptop. Oh, that's the combination. I misread that. Well, then let's just use the one where there's most in stock. So let's use this one. We will just use U. C347223, I choose U. Alright, and then we also need to specify the capacitor. Oh, hey Samuel, already late again. So the C small, I never put in a value for that. I guess, what would be a good value? I knew it was 21-ish before stopping. Capacitor on input and output. No, we don't have space. It's already pretty cramped on there. And on the input line, which is the 12-volt line, all the LEDs are connected to, and they have internally a capacitor across ground and VCC, so there should be enough capacitance. Like, where should I add a capacitor? I need all the ground planes. No, we don't have lots of space. Oh. We need all of this ground plane. I mean, I could add the capacitor right here. Let's look at the data sheet again, what capacitor value they want. On the output at least. No capacitors on bottom, because we can only pick and place on one side. 10 microfarad, but this is electrolytic capacitor. Is 10 microfarad a good value? I can't remember. Let's see. I mean, it doesn't matter. Alright, so let's look for a capacitor, 10 microfarad, and then 0806. What are you? Oh, 0805. Multi-layer ceramic capacitors. What's the cheapest one? Oh, that one is hot. No. 16 volts should be fine, since we are only having 5 volts. Tolerance plus minus 10%, whatever. Oh, X5R, I know about the temperature coefficient, so my professor told us once about the temperature coefficient, and that there's a specific number for good parts, for high quality parts. Oh, this one only costs 0.003 cents. And this one already costs 0.01 cents. Oh, they are all out of stock. Probably should have looked at that first. So this one it is, I guess. From Samsung Electromechanics. Alright, you are in. LCSC, part number, yes. I heard can't touch this tune. And should we also put one on the input of the AMS as Chris suggested? Yeah, I think Chris is from Germany. So all the other things we won't need them. We won't need a part for that because JDC doesn't have it, and the connectors are all optional. Guten Abend. So paste. Let's read that. Sorry, just came back. Right, let's add you over here. And you are going to be C3, I guess. Where's C1? Where's capacitor 1? Oh no, it already did it for us. What a nice software. So now where do I do wire? Just like so. So are you happy now, Chris? Did it already update the footprint for us? Oh, the part number and everything. So now we need to go to site A. And how do we add the component now? Place component. I think it worked a little bit differently. Footprint. One on the output would be necessary too, but if it doesn't work, in the end, it's your problem. Yeah, I added the one on the output. There's already one on the microcontroller. That one is over here, which is directly connected to the output of that one, so we don't need that really. But how do I now add the component, the C2? So we got C1 here, but how can I tell him to add the component from here? Because I added the component in the schematic here. I don't want to hit update PCB. Alright, I don't know how this software works. It's very weird. How can I place Dr. Edgar Wolken Tötje? The bottom layer is the nicest. What is with the 5-volt net? Oh, this one is not connected yet, doesn't matter. It's internally connected. How can I get the C2 on here? How? I added C2 here. Why is this one red? Oh wait. Why is that red? And the other ones are green. I technically wanted to close the stream 17 minutes ago, but now I have this issue here. Why is this connection red? Like, does it... No. So, C2, how do I get you on the board? Xeon is not streaming in ours, so just carry on. Report error. I am having error. Why are you red? You can change the color of everything, huh? So I want you to be green. Ooh. In ours. So, is there someone who knows how I get this component from the schematic into the PCB? All right. It's normal. So this one is C2 now, but it's not connected, obviously. Yeah, but the issue is that I have 3 different PCBs. So, update PCB. Yes, check nets. And then the part is not there at all. Ah. Wait a second. Oh, you gotta be kidding me. Ah. Alright. This will be a long stream. Oh, I hate this software already. It's messing with my head. Alright, so tool, design, import changes. No, keep going. And then we have the issue, oh, I can't find the footprint on the server. Maybe we will need to do it a little bit differently. All right, so give me 1 second. So the options are right now either update the PCB in here, which will probably be the smarter idea, and then re-upload it. So we go to PCBA, project, then this right here, then we will add the, alright, we can do D or C for duplicating it. And then we do this, escape, edit, C2, done, save, create netlist, generate netlist, save, close this, go to the PCB layout. I have secret power, muted test. Also got sorry about that. Oh no, not again. I won't open that link. Alright, so netlist. Update PCB, yes. And there's our capacitor. And now we have the issue of putting it somewhere. Could probably squeeze it in here. So over here I meant. Now this one is for the input of the AMS. Me no like. Maybe do it like so. But then we will have an issue. No, those components are very, very close. I think it will be fine. But we will have an issue to get the 5 volts through. Because if we just put the capacitor over here, then it won't do much for the AMS, because then the ground connection is very long. So this is pretty much our only option. Let's look at his design once more, because I don't think that he has a capacitor either. Oh no, he has. Yeah, I mean like this. And then move it as far as we can to the right, I guess. And then we need to reroute this a little bit. So let's start over here. No. Remove this. And that should be fine. So are you fine, or are you happy now with the component in place? So now we have to do all this stuff again. Plot, save, no, plot, generate drill file, map file, close, plot, close. Close, then we do the zippity zip again, side A, save, replace, yes, close. Then on the easy EDA side, we go to side A and then do file. Can we delete it? Delete side A, yes. Then over here, we now need to delete all of that and then redo all the stuff again. That will be fun, wait. Let's copy those values real quick. So that is the ATtiny. We have the resonator, res. We have the capacitors. Where are you? Cap, and then we have the AMS. All right, and then this will be the last thing we will do. Vio, again, thanks for 2 more euros. Invi has no scare for police, so he's got a clean slate. Oh, you heard the police siren? Is that all? The resonate or the diode? I forgot the diode. Diode. Now we should have all. So let's remove that. save file open KiCad. Yeah, I'm in the middle of this city and there's a lot going on always. Alright, so can we do that? Johnny will be arrested though for chatting too much to a fellow from Netherlands called Maiko. Probably. So now we do file, save as, and then site A again to existing project, save, illegal URL pasting. Oh, you guys. Right, let's copy this and then paste it somewhere here. Save that. Don't save, and now we need to. Did I just see there? Weird visual glitch. Alright, so let's really quickly add the LCSC and just have it off screen. So diode part, capacitor, LCSC, this one as well, LCSC, the C whatever, the AMS itself. What does AMS stand for? I have no idea. It's just the part. It's like 555 timer, I guess. So we also need the resonator, LCSC, and then the ATtiny itself. Right, so ATtiny. Let's make sure these are all correct. So this should be the ATtiny. The resonator should be C34 something, so let's enter that. Then the capacitor should be C1713. Part number, can you open that? And the, what did we open? So the ATtiny is correct. This one is correct. Capacitor is correct. And then now the diode and the AMS. So diode should be that. Yay, computer froze while watching you and compiling GNU radio on my phone right now. Nice. And then this one is also correct. And then the AMS. Right, they are all correct now, so we can save this. And then I can end the stream right now. So let's do it like this. So there you can see what we did today. The next stream will be on Thursday at the same time, 19 o'clock until 21. even though we always tend to do longer than that. Modern-ish compilation demanded a lot of resources. I shouldn't have opened it at the same time. So, we played a little with the software of the controller, and there's still much more to program. We looked at the schematics and fixed some things. And after the stream, I will order 5 of each PCBs and hope they will arrive next week so we can start putting together the first prototype. I will also try to source some of the components. Probably the LEDs won't be here until next week, but we'll have to hope for that. See you all. Not sure if I will be on Sion's chat. Yeah, I will probably not be on Sion's stream because it's so late, but I hope you enjoyed the stream today and maybe learned something. I learned a lot, as always. And I hope and I wish you a nice evening or morning or whatever. And you will see me on Thursday. Yeah, thanks for today. Yeah, see you Henrik, see you Maiko, see you Samuel, see you Johnny, see you Vio, see you Bolukan, see you Chris. Did I miss someone? Henrik. Yeah, see you all and have a good night. Bye bye. Alright, now. Alright, bye.